Brian Cox says, "It can be surprising. The sun will shine differently because it's only 600 light-years away. Tomorrow /N. The red giant Betelgeuse is about to explode. The images show that Betelgeuse is very faint and very unstable. Scientists around the world look forward to this unique event. At a distance of only 600 light-years, we on Earth can see these sights with the naked eye. Betelgeuse explodes and briefly outshines the entire galaxy. Even weeks later, we can still see the remnants of this supernova. What will happen when Betelgeuse explodes? According to astrophysicist Brian Cox, for a few moments we can see the moon as blinding as any other day in the day. We may be blinded for a few moments and see a very bright flash. If a star explodes at night, the world will be as bright for a few moments. Betelgeuse is about to explode. It goes without saying, but on a global scale soon could be 100,000 years or just a day. The crazy thing is that Betelgeuse can explode early. Because the light from the supernova travels through space for 600 years before reaching us, we see the light beam 600 years after the explosion itself. This idea shows the most important parts of the world in a wonderful way. When a supernova is detected, it becomes interesting to us and we follow all the small changes in the star. In 2019 and 2020, red giant Betelgeuse experienced a significant decrease in brightness, later known as the Great Diminishing Event. The sudden decrease in brightness led to speculation that the star was about to explode. Other experts were convinced that the star would rise shortly before the final event. Scientists eventually discovered that the darkness caused by a large dust cloud blocked some of the star's moons. The ancient nebula star Betelgeuse may have experienced something like a mass ejection, similar to what is known from our Sun. The star throws a lot of material into the surrounding area. Betelgeuse is 1,000 times more massive than our Sun, and the ejected matter is much larger. The lack of light was caused on the one hand by the dust cloud, on the other hand by the coldness of the star due to the loss of material. In March 2024, the American Association of Variable Star Observers reported that Betelgeuse also experienced a decrease in brightness of about 0.5 magnitude. The researchers observed this lack of light and anxiety and motivation since the end of January. This mysterious moon is also a sign of lack of knowledge about Betelgeuse. Abnormal changes are signs of an impending explosion. Once again, the scientific community thoroughly investigated and found that the darkness is a direct effect of the Great Eclipse event of 2019 and 2020. Now, we have new research and simulations from astronomers at the Max Planck Institute for Astrophysics that show that Betelgeuse's surface turbulence can lead to misunderstandings. So, what exactly is the red supergiant that we will see explode soon? The binary star and the Betelgeuse theory, although Betelgeuse is on its way to becoming a supernova, where the red giant is now still a mystery. Betelgeuse is not just a red giant. Its behavior is different from other stars of this type found in space. There is an unknown reason for this. Some of the star's features don't quite match up, leading scientists to come up with an intriguing theory. Betelgeuse may be the result of the merger of two smaller stars. In this case, we don't see an old star going supernova, but two stars. The star rotates very quickly and has more elements such as nitrogen in its atmosphere than red dwarfs. In simulations carried out by astronomers, it was shown that Betelgeuse was originally a binary system of two stars. One of these stars absorbs the other's mass and eventually merges. This process can disrupt the interior of a newly formed star and push heavier elements into the upper layers, explaining the nitrogen abundance. This combination makes the star spin faster. In general, red supergiants rotate faster. However, the simulation showed that the further transfer of angular momentum could be explained by the merger of the two stars. The transit study also found the star's rapid rotation to be false. The activity on the star's surface leads to optical illusions that resemble an expanding spiral. Therefore, it is very difficult to assess the true nature of Betelgeuse. The best scientific knowledge at this time is the action of the powerful and deep convection currents, which constantly push billions of tons of material to the surface of the star, making the core unstable. Betelgeuse is still in the final stages of development. Scientists estimate that the star is in a period of burning, lasting 1,000 years. After this phase, Betelgeuse will explode in decades instead of thousands of years, as previously thought. Betelgeuse will dim again in 2024, and the changes in brightness may be the first signs that the star is nearing its end. Betelgeuse is important to us. It's not just a star. It is one of the brightest stars in the Orion constellation and has had a special meaning for humans since our species first gazed upon the sky. This star is big, red, and very popular. Betelgeuse may have exploded into a red giant over 100,000 years ago. From the 18th and 19th centuries onward, William Herschel, one of the most important astronomers of the time, classified Betelgeuse as a variable star that changes its brightness over time. The decisive breakthrough in our understanding of Betelgeuse came in the 20th century with the development of spectroscopy. In the early 1900s, astronomers were able to analyze the chemical composition and temperature of distant stars for the first time. The spectroscopic study of Betelgeuse showed that the star was a red supergiant in the late stages of its evolution. Edwin Hubble, known for discovering the expansion of the universe, also contributed to the study of Betelgeuse in the 1920s. Hubble used the newly developed techniques of astrophotography to study the size and structure of the star. In the 1950s and 60s, the invention of the radio telescope ushered in a new era. This technology made it possible to observe Betelgeuse in different wavelength ranges, providing completely different insights into its physical properties and atmosphere. Finally, in the 1990s, the Hubble Space Telescope revolutionized Betelgeuse's surface observations, allowing us to witness the irregular brightness fluctuations for the first time. Since then, researchers have divided the fluctuations into several almost regular cycles. Since the beginning of the 21st century, we have had the next great technological innovation: interferometry. This allows astronomers to make extremely precise measurements of the surface of stars. Observations with a very large telescope in Chile have shown us exciting images of irregular surface activity and huge convection cells. For the first time, we have only known the details around Betelgeuse for a relatively short time, which makes it difficult to make an accurate prediction. The most recent observations in 2024 showed another significant dimming, supporting the theory that Betelgeuse is heading for a supernova explosion. Modern technologies, such as high-resolution spectroscopy and computer simulations, now allow us to precisely track the exact state and future evolution of Betelgeuse. While Betelgeuse remains an object of intense scientific study, the chronology of its exploration demonstrates the progress of astronomy and humanity's growing ability to unravel the mysteries of the universe. What do we really know about supernovae? Our science sometimes seems so self-assured, and it's easy to get the impression that researchers are in possession of real truths. But especially when it comes to the universe, many theories and opinions are still based on pure speculation. We know the true nature of supernovae just as little as we can precisely examine Betelgeuse. Certainly, people of many eras have witnessed huge explosions of dying stars, but they have usually been misjudged. The first documented observation of a supernova dates back to 185 AD when Chinese astronomers observed